What you're looking at right now perhaps wouldn't remind you of a galaxy. This galaxy has the same size, mass and element composition as our home, the Milky Way. But when we look at them side to side, we cannot help but notice the massive visual differences between them. While both galaxies started at the same point, clearly, something has gone horribly wrong with this galaxy. The galaxy is so dim, broad and heavy that it is almost invisible to every single detection method. If not intentionally looked for, it simply gets filtered out as nothing but noise. The reason for this phenomenon is dark matter, one of the biggest mysteries of the 21st century physics. This is the Dragonfly 44, the dark twin of the Milky Way. Take a look at this picture. What you're seeing is a phenomenon known as gravitational lensing. To explain this briefly, if a gravitationally massive object is placed between us, the observer, and a distant point, the light from that point that is directed to us gets bent. As a result, we can see an object at two places at the same time. An extreme example of this was shown by JWST. All those galaxies are in reality the very same galaxy. But if we take into account the apparent mass of those galaxies, something doesn't seem very right. The star mass alone wouldn't be enough to result in these extreme bends. This was just one problem out of many that were to be discovered. Galaxies with their own mass and forces, by all accounts, shouldn't be able to hold themselves so tightly. They don't appear at least to have enough mass and thus gravity to stick together. But contrary to that, stars don't swell out of those galaxies, and the speed of the outer parts compared to the inner is much faster than expected. This all means one thing. Inside our own universe, there is another shadow universe of a kind. It is made out of particles that do not interact with regular particles in any other way other than gravity. Those particles neither combine to form atoms nor decay into quants. This we call dark matter. Dark matter and dark energy represent almost 95% of our universe's matter and energy. This means that we can see, hear, touch and feel only an astonishingly small 5% of everything the universe can offer. But despite that, as you're sitting down watching this video, trillions of dark matter particles are passing through you. They are piercing through the universe itself. Dragonfly 44 is something known as a dark galaxy. It has almost no stars or galactic structures. It is a galaxy made up almost entirely, 99.99%, out of dark matter. And despite being the size and mass of our own galaxy, it has less than 1% of the light the Milky Way emits. It is evident that during its youth, some violent event robbed it completely out of stardust. It left nothing but aging stars, black holes, and a giant halo made up of dark matter. Or no dark matter. Some scientists, going against the flow of the river, proposed that dark matter isn't the explanation for those phenomena. Instead, they proposed Modified Newtonian Dynamics, or MOND, tweaking the laws of Newtonian gravity in a certain way. By those changes, gravity should diminish at distances at much lower rates than classical Newtonian physics suggests. This would not only allow us to have a universe with no 95% mysterious matter, but also explain the Dragonfly 44's properties much better than our current theories do. This could have been a major victory for the MOND scientists. But recently, a new study added more to this mystery. Dragonfly 44 turned out to be extremely old, almost 12 billion years old. 12 billion! Think about how long that is. That is almost as old as our own universe. And MOND theories alone cannot explain how this galaxy has existed for such a long time. That Dragonfly 44 has held together implies that it has a considerable dark matter halo after all. Well, with that being said, we are nowhere close to even start unraveling the mystery that is dark matter. A lot awaits before we can know the origin and the implications of dark matter. The fight in science still wages on.